On ratios and proportions and proportional reasoning. In order to use those things, we're going to need to have a really good understanding of fractions, specifically simplifying fractions. So we're going to get some practice doing that today. We're going to take notes on this side of the paper, and then on the other side, there's some exercises that I want you to do. So please follow along for now. So our first example says that we want to write each product as a single fraction in lowest terms. So that means our first step is going to be to do what? Multiply and then simplify, exactly. So what do I do when I'm multiplying fractions? Yeah, we're going to add a 1 under the 12, and then what do I do?
Go across.
Yeah, go across. What's 12 times 15?
A big
Good, it's 180. Not too big. And what's 1 times 28? Perfect. Is that in simplest terms? No. So, correct. It's okay that it's improper. That doesn't bother me so much. But it will be easier to use this fraction if we simplify it. I told you how to simplify it using your calculator, but I'm going to show you how I would do it by hand so that you understand what your calculator is doing. And maybe you can appreciate it a little bit more. All right? So what we're going to do is we're going to write each of these numbers in terms of their prime factors. Prime factors. Does anybody know what a prime number is? You do?
Yes.
Tell me.
Prime. P-R-I-M-E. Only factors is 1 and me. Factors that divide evenly.
Perfect. That's amazing.
I know that's a take a first grade.
So yes, so prime numbers only have a factor of 1 and itself. Okay? So they're kind of like, I think about them as, you know what atoms are? Like in the universe is made up of like atoms. Every single thing can be broken down into like those teeny tiny little things. Yes? That's what prime numbers are for like all the numbers. Every single number can be broken down into prime numbers. So let's go ahead and we're going to factor out these numbers. Break them down into their prime numbers. So we start that by making a factor tree. Can you think of two numbers when multiplied together? Could I get 180? 90 times what? Perfect. 90 times 2. Is 2 a prime number? Yeah. Is 90? No. What two numbers multiplied together give me 90? Good. 9 and 10. Is 9 a prime number? Can you think of two numbers when multiplied together give you 9? Perfect. 3 times 3. Is that better?
Yeah, thank you.
3 times 3. Is 3 a prime number? Yeah. Only 3 times 1 gives us 3. What about 10? 2 times what? Good. 2 times 5. Is 2 a prime number? We already decided it was. Is 5 a prime number? Yeah. So that means I can make up 180 out of 2 times 2 times 3 times 3 times 5. So I'm going to rewrite my numerator as a multiplication problem between all its prime factors. Right? If you plugged in 2 times 2 times 3 times 3 times 5 in your calculator, you'll get 180. And then let's do 28. Is 28 a prime number? No. What two numbers multiplied together give us 28? Good. 7 times 4. Is 7 a prime number?
How?
Yeah.
7 times 4?
Is 4 a prime number? What two numbers multiply together give us 4? 2 and 2. Perfect. So I just broke down 28 into its prime factors. So now I'm going to change my denominator to 2 times 2 times 7. What does the numerator and the denominator have in common? 2 2's. Perfect. Right? These are the same, and those are the same. So I'm just going to rewrite this in a little different way. I'm going to take 2 over 2 and multiply it by the other 2 over 2, and then I'm going to multiply it by the rest. I know, aren't you appreciative of your calculators? So what is 2 divided by 2? 1. Same with this one, right? So those, we say they cancel out, but really what's happening is they're being divided. So then what's left?
3 times 3 times 5 over 7.
Perfect. What's 3 times 3 times 5? Good, 45 over 7. And then I'd like you to do the same thing with your calculator. So plug in 12 times, and then 15 over 28. 12 times, hold on, I'm pulling it up. Just putting in the original problem. So 12 times 15 over 28 gives me this. How do I change that decimal into a fraction on the calculator? Math, enter, enter. 45 over 7. That's exactly what we got, right? Which one is easier to do? The calculator, right? You can use your calculator anytime, but I do want to show you how to do this by hand because you should understand what the calculator is doing, right? All right, let's do this next one. So what do? I got 125 times 64 over 100. What am I going to do to multiply that? Yeah, 125 over 1. And then what? Multiply across. What's 125 times 64? And 1 times 100? 100. Good. So if I were going to do the same thing, it would take quite a long time to break 8,000 down into its prime numbers, right? So let's think about something else. I can rewrite 8,000. That's the same thing as 100 times what? Not 8, 80. Yeah. So now I've got 100 times 80 in my numerator and 100 in my denominator. What does the numerator and denominator have in common? Yeah. So I could rewrite this as 100 over 100 times 80. And what's 100 over 100? No. No, 1. And so what's 1 times 80?
20,000. 30,000.
80.
40,000.
No.
So I hear 50,000. No?
50,000.
Okay. One more time. In your calculator, let's just check our work. 125 times 64 out of 100 gives me 80. Cool? Make sense? Is that clear? Huh? Check again. All right. So now, you're going to do something like that on the back of your paper. You're also going to do something like this where you're going to compare fractions. Comparing fractions. Which one is greater?
6/17.
So when we have two fractions with the same denominator, all you got to do is compare the numerators. So these two have the same denominator, right? 17. Which one is bigger, 7 or 6? 7 is bigger.
I thought the smaller one was always bigger in amount.
So that's if
They got the same bottom number. So you 17 is big.
when this
Like normal numbers now.
yeah, when the denominators are the same, you compare the numerators and just look to see which numerator is bigger, and that'll be the bigger number. If you have the same numerator but different denominators, then it's just the opposite. So which is bigger, a third or a fourth? So do you guys know what A&W is? Like the fast food place? Yeah. So they used to have quarter-pound burgers, and then they switched it to a third of a pound. They made their burgers bigger. And yeah, as like a marketing scheme to like try and bring in more customers because we have bigger burgers than everybody else's quarter pounder, right? But Americans are not very good at math, and they looked at these two numbers and just thought, well, 4 is bigger than 3, so a quarter is bigger than a third, so it didn't really work.
That's stupid. Americans are stupid.
Hey, I think I'm really smart.
Yeah, no, this is like an actual thing. So since you guys know that a third is bigger than a fourth, you are smarter than like the majority of Americans. Good job. How about 2/3 and 1/3? What's bigger? Exactly. What's bigger, 1/4 or 3/4? There you go, right? And just in case you get confused, because I still get confused with these sometimes, the alligator eats the bigger number, right? Okay. So now we're going to look at examples where the denominators are different. Different denominators, different numerators, like this. 5/12, 7/36, 11/24. How are we going to figure out how to put them in order from greatest to least, or least to greatest?
Maybe from highest, like bottom number to the lowest.
Is that going to work though?
From least to greatest.
So what we're going to do, I'm going to show you two different ways of thinking about it. The first way, we're going to find the least common denominator. Least common denominator. You're going to get common denominators. So what are my denominators here?
12, 36, and 24.
When we want to find a least common denominator, we need to think about least common multiple. Least common multiple. What are the multiples of 12? What, Cameron? So that's going to be factors. Multiples. What would be a multiple of 12? So those are factors. Those are numbers that make up 12. What are the multiples of 12? Yes. 12 times 1 is 12. 12 times 2 is? 12 times 3 is? 12 times 4 is? 12 times 5 is? 12 times 6 is? 72. How about 36? What's 36 times 1?
72. Wait, no. Next one's 72.
Good.
My bad.
What's 24 times 1? 24 times 2? 24 times 3? What is the smallest number that all three of those lists have in common? 72.
Wow. Oh.
You remember this from way back when?
No. What school did you guys go to? What school? Oh, you learned this in the middle school? Well, you paid attention. That's not fair. I made it here. So.
There's actually no. I'm not gonna do that right now. So now we know our least common denominator is going to be 72. Okay, so 5 over 12, 17 over 36, 11 over 24. Let's convert these so that they all have the same denominator. 12 times what gives me 72? 6. What's 5 times 6? 36 times what gives me 72? 2. What's 17 times 2? 17 times 2, Dylan. 34. There's a calculator, right? That's okay. Okay. 24 times what gives me 72? 3. What's 11 times 3? All right, so now these three fractions all have the same denominator, right? So can we put them in order from least to greatest? What's the least? What's the smallest one? 30 over 72, or 5 over 12. And then what's next?
33 over 72.
Yeah, 11 over 24. And then last? Perfect. Okay, so that's one way of comparing fractions like that, seeing which one's the biggest, which one's the smallest. You can also do it by writing each of the fractions as decimals. So let's try that. How do I change a fraction into a decimal? Yeah, divide it. What's 5 divided by 12? Yes, 0.416 repeating. What is 17 over 36 as a decimal? Miley, get it away. You too, Jocelyn. 0.472 repeating. And what is 11 over 24? 0.4583 repeating. Perfect. So can we put those in order? From least to greatest? What's the smallest one? Yeah, 0.416. And then 0.4583. And then perfect. Okay? So those are two different ways of putting fractions in order. You can find the least common denominator and then just compare the numerators. Or you can just use a decimal to do it. All right? Be clear?
Can you kick that up?
Yes. I want you to start working on the back. So start with numbers 3, 4, and 5. 3, 4, and 5. Once they're done copying down the notes from the board, I'll go over number 1 with you. Remind you how to do that. So start with numbers 3, then 4, and 5. I'm going to have you do 1 and 2, but I'm going to show you how to do number 1 in case you forgot how to find the greatest common factors. So you're handing this in at the end of class today. I think they still have math in Mexico.